Let's try to prove the quotient rule. So in the quotient rule, we're trying to look at the derivative of u over v. So it's a function u divided by a function v. So I'm going to use u over v in a lazy way instead of saying u of x over v of x. And in a similar way, instead of saying u of x plus delta x, I'm going to say u plus a little bit of u. So that represents the function u at the point x plus delta x, and v plus a little bit of v to represent the bottom of the fraction v of x plus delta x. So y plus delta y is u plus delta u over v plus delta v. So if we want to get delta y, let's put that a bit higher, delta y is equal to u plus delta u over v plus delta v minus u over v. So I'm going to multiply top and bottom of this one by v, and multiply top and bottom of this one by v plus delta v, just so I can add them up. And I get uv plus v delta u minus uv minus u delta v all over v brackets v plus delta v. And obviously this one cancels this one, and that leaves me with, on the top, v delta u minus u delta v all over v plus delta v. But now, because of the dividing by delta x, I've also got a delta x down there. Okay, let's split this up into two fractions. I've got v over v brackets v plus delta v multiplied by delta u over delta x minus u over v plus delta v multiplied by delta v over delta x. And this v cancels this v. Time to take the limit as delta x goes to 0. So a reminder of the limit rules that I'm using without proving. If I've got two things added up, or in this case subtracted, I'm allowed to take the limit separately and then add them up. And if I've got the limit of two things times together, then I'm allowed to take the limit of the first one and multiply it by the limit of the second one. And if I've got the limit of something nothing to do with x multiplied by f, which is to do with x, then I can just pull that alpha out and just look at the limit as f does whatever f is doing. Sorry, I don't know why I pressed there. Right, so those are the rules we're going to use. So look at the thing we've got to take the limits of. We can take this limit separate from this limit using the first rule. Then we can look at this limit and then multiply by this limit and this one times this one and break it all up like that. So what's that going to give us? Well, we've got the limit as delta x tends to naught of 1 over v plus delta v multiplied by, well, the limit as delta x tends to naught, actually I'll just write it down, delta x tends to naught of delta u by delta x minus, well, actually I can pull this uv out using that third rule, because this u has got nothing to do with delta x and nor's the v. The u and the v are just u of x and v of x, so all they depend on is x. This has got nothing to do with them at all. So they can pull out the front and just wait. And then we've got the limit as delta x tends to naught of 1 over v plus delta v times the limit as delta x tends to naught of delta v over delta x. Okay, how much of this is obvious? This is obvious. This is equal to du by dx, that's the definition. And this bit's obvious. This is equal to dv by dx, that's the definition. And this bit's obviously just u over v. And the minus is obviously a minus. And then we've got the same thing to look at. Now we can use, I said we weren't going to use it, and now I am going to use it. So I'm going to use the fact that the limit of a fraction is equal to the limit of the top divided by the limit of the bottom. And all of these things are things that you will prove when you get to university, and you'll find out which strange functions it doesn't work for. But all the ones we're using, it does work for, so it's okay. So, using the limit of the top and the limit of the bottom, on the top we've got a 1, on the bottom we've got something which is nothing to do with delta x. We've discussed in the proof of the quotient rule no, this is the quotient rule. We've discussed in the proof of the product rule already that if you've got a little bit of x, delta x, and a little bit of v, delta v, and this is the graph of y equals v of x, then as you come in with your x smaller and smaller, and your delta x smaller and smaller and smaller, then your delta v, not the fraction, just the delta v, just this height here, as you come across and make delta x 0, delta v will also become 0. So down here, this delta v is going to basically become 0 once delta x becomes 0. Not that it ever does. And delta x going to 0 there means delta v goes to 0 here. Okay, nearly done. Let's make some room. Okay, that's my limit things. Can go there. Right, where have we got to? dy by dx is equal to the limit as delta x tends to 0 of delta y over delta x, which is 1 over v times dv by dx minus u over v times 1 over v times dv by dx, which is 1 over v d, well, actually no, that's not very nice. Let's write it as two fractions. 1 over v dv by dx minus u over v squared dv by dx. Now if we multiply top and bottom of the first one by v, then we can write it in the usual way that we're used to. V du by dx minus u dv by dx all over v squared.